rip those out, you can't put them back in. So please keep in mind, I will be asking for some stuff that's in there. I can't take credit for that entire book. It was started by a prior instructor, and I've carried it forward. There is one drafting civil-based text I've been able to find on the market, and it's not very good. So in essence, we went this route, and it benefits you in that you get applicable knowledge, and we're not charging you for it.
I like that.
Yeah, you bet. So that is we'll be using that text as we move forward. Now, it's not totally up to date, just so you know. There are some things in there we will change as we go along that just haven't had time for the editing process to go through. But we will be jumping into it shortly. All right, let's go over the syllabus so you get an idea of the course. I handed these out. So we're in drafting 152. The projects we're going to take on is a site plan tracing project. We are going to do a commercial site plan in here, and you can add another drawing to this right off the bat. Guess what that one might be?
Ours.
Residential site plan, as we're going to finish our site plan in there. And I really like those because we have two different concepts when we look at a commercial site versus a residential site. In essence, there's different end uses of those sites, so we have different considerations. Now, when we say a tracing project, this is a real site plan that's been put out by EHM. The structure was built back in the 80s. And we've got the originals of it. I'm going to give you approximately half of this drawing, and then you will then transpose from the existing drawing onto it. And the goal here is you're going to do a better job than the drafter did for EHM. Okay. But we also want to make sure we understand the components. So, and I'll mention this again when we get into it, when you're drawing it, and you're drawing in the parking spaces, don't just draw them in, measure them. Understand why they're in the situation they are. Are they inclined? How much vehicle capacity or storage do we have in that? Where's our turning lanes? You know, think it through. Okay. I think certainly as this last one's gone in, you found that visualizing some of this stuff is pretty hard, right? If we don't really know what it is. So we need to kind of think about it and maybe even step out and look at our parking and say, why is it designed this way? You know, I'm just using that as an analogy. There's a lot of other things on there. So that's our first one. We'll start this on Monday. I'll give you today and tomorrow to work on your architectural during class, and then we are going to start this course formally with drawings on Monday. Okay. So if now just so you know, your architectural drawings won't be due at that time, but any more work you do on them, you need to plan outside of our time slot. Next thing we're going to do is we're going to move into a real standard type of drawing for civil. And we're about the only folks that use this drawing. We call it a plan profile. Okay. I don't have any examples up here. We lost the two I had as we moved. Is that one over there? No, that's subdivision over there. But we'll talk about this one. In essence, what it is, it's a plan view, a lot like what you did with the site plan or a rough plan where we're looking down on the structure, but included with it is a full section of the project. Okay? And the full section always follows the center line of the project. And it's kind of a unique type of structure. And now let's say we're drafting a road when we're doing a plan profile. And the road probably does something like this. Well, underneath it, what we're going to do is we're going to draw a full section. Now, my full section will go something like this, where it starts here on the side. That would project straight down to the start. But then, what we do is we follow the center line of the project, take it like it's a rubber band, and we're pulling it straight, and we're drawing that section in a straight line. And it works really well for things like sewers, any lines below the surface, of which you have a bunch. Electrical, water, even data lines, all of this stuff, roads, canals, all of these types of structures. This is a great drawing for it. So in essence, what we're doing, we're looking down into the earth here, okay, and showing how things are going to go. Real standard type of drawing in civil. We do hundreds of these in the course of a project. So we'll do one here. We're actually going to do it in a sewer instance. You will also have some that we will do on our final project that has to deal with land development. After that, we're going to go to the mainstay of the civil industry. This is what keeps civil firms in business. Yeah. It's kind of like what drawing is continually coming up and pays the bills. It's platting subdivisions, right? The land development around towns. This is the one that is very detail oriented. It's actually a legal document. If there is a property dispute that goes to the court of law, there's two things that are going to happen immediately. A surveyor is going to get called and establish property boundaries, and the original plat drawing is going to get pulled out of a drawer and matched up with what's out in the field. Right? Your name will be on these. They will go to a court of law. Most of them are in and have seen that type of stuff. So we need to really kind of cross our T's, dot our I's on these things. Right? No attention to detail is too small. Right? Because, you know, in essence, we're talking about people buying property. They get very picky if your property line is not right.
So if it is wrong, or there's often it goes to, are you liable for something, or is it just?
No, the engineer that stamped it is liable for it. And yes, we look at these many, many times before we let them out the door. Okay? But it is a standby. Every civil engineering firm that's around the town does these types of drawings. Okay? It's the one that continually comes up, and like I said, it buys the shoes for the kids and Christmas presents because it always comes up, and it's a good source of income for these firms to keep the lights on. Okay? After that, we're going to come to our final project. You're not going to do this one. Okay? Normally, we do a road project through the Harrod Field over here, and even if we do a final project, I usually still do this one. I don't think we're going to have time this year. We are further behind than I've really kind of ever been. So I don't know that we are going to have time for it. Now, what we do have going is we do have a final project that will start probably mid next week, depending on the weather. And that we're going to take a field out in the town of Filer that's on one of the school systems, and we're going to regrade it, and we're going to put a softball field on. Okay, so we're going to have to design all of that, how we're going to do the bases, how the field's going to be laid out. We're going to have some replanting to do with it. We're going to have to build some fences, backstops, dugouts, the whole 9 yards. We're going to design it all up. That will all be built this summer. Okay, so you'll get to see your designs come to fruition. But we're going to actually also, the last thing we do at the end of the semester is we're going to go out and stake this, because they're going to start construction on it about May 18th, I think they have planned. And so we're going to stake it for them to get in with backhoes and start ripping up the land, and we're going to have everything identified and where it goes. And then if you stick around through the summer, if you're not out working or whatever, we will probably be asked to come out and support that also with more survey. Okay, so it might be an ongoing project through the summer that we will run as part of the drafting club. We're not getting paid for it, it's a community service deal. Okay? But it's nice where we can fit that into curriculum and take care of our community too, because your community is taking care of you. They paid for this facility, they paid for your computers, your software, all that, so it's nice to give back. Okay? Just so you know, we will work in teams on that, okay? But you will be responsible for your own drawings. Okay? There will not be team drawings. You will have to produce all of your own drawings. I will give you some more information on that one next week. Okay? So we'll get started on that right away. Obviously, the length, 6 weeks, 6 credits. How many weeks we got left of the semester?
4.
We don't have 6 weeks. Okay, now with that, I'm still going to go through all the curriculum, but I am going to shorten a couple drawings, okay, so that we can fit that in. Okay. So when we come into these top 3, I'll give you portions of it so that you don't have the redundancy of doing the whole thing. Okay. I'll give you portions of it to speed you up a little bit. As far as the textbook, you're going to have 2, the one I just gave you this morning, and we are also going to be using your architectural text. I've got section 3 listed on here, of which we gave short rift as we went through. It's a site planning section. There are other areas we may be into. Okay. So please have that book available as we go through this program. I don't think your Bertolini text really has anything that we're going to need in it. Okay. Here's what we're going to cover right here. We're going to start the way all civil projects do with maps. In essence, if you're a civil drafter, you're a map maker. Okay? You really are. We do a lot of them. So therefore, we need to be able to read them, and we need to know what different types of maps are out there. and the information they are meant to give out. So we will start this tomorrow. Then we're going to go into all the symbology. Our drawings get very busy. We use a lot of symbols. Imagine trying to draft like a town for a road map or something. Do we draw the hospital in? No, we use a symbol for it. Do we draw the school in? No, we don't. Okay, we use a symbol. Okay, so we use a lot of symbology. You can take it down to the street level. Do we draw street lights in? No, we don't. Okay, we use symbols. So there's a lot of symbology in here. Scales. We get really funny with our scales in the civil industry. This is an engineering field. Do you think engineers, these are kind of a personality type of people? Majed.
Yeah.
He's an engineer from another country. But Majed, what do you think about the base 12 unit of measure?
What?
The base 12 unit of measure. Or the inch in the foot. Okay. You probably hate it. I've heard you say, why aren't we doing metric on everything in here? Because you do not like it. It's a base 10. We take the inch-foot system and we change it because we want to go base 10 because we need to be able to do that math in our head. So we will be going decimal feet in pretty much everything we do. Now, AutoCAD doesn't know what we're working at. We're going to kind of fool it. We know how it's working. We'll use a decimal system and it's always going to be decimal feet. Now, with that said, you need to get kind of fairly good at converting from inches to decimal feet. So you'll know fairly quickly that if I'm dealing with 6 foot 3 inches, I don't type that in as 6 foot 3 inches. I type it as 6.25 because 3 is a quarter of 1 foot. Okay? And you'll probably have these numbers memorized fairly quickly, okay? Because we see them all over. 3, 4, 4 is a third, right? So it's 0.33, 0.67, or a whole. Okay? That's 4 and 8. 3, 6, 9, those are all the quarters. 6 is a half, right? I think I'm going to take a little bit. Missy's shaking her head. I can't do the 16s yet. Cheryl gave me a couple ideas on that, and maybe we'll take today and follow some of the recommendations she made to me and see if we can't short circuit that a little bit. So, with that said, we're going to kind of mess with the computer a little bit to get this going. You're going to like it once you work in it a little bit. It's actually much faster than the architectural system. Much faster. Okay. Legal land descriptions, we do have to go into this. We can't really build anything if we don't establish land ownership. Okay. Now, it may be BLM, maybe Forest Service, maybe private, maybe local government, whatever. We still have property boundaries we have to deal with. So we got to know them very well. Contours. How do we get the Z dimension on our drawing? We kind of mentioned them a little bit when we did our site plan, right? Remember going out there with the level and kind of taking some measurements and then bringing it back in and doing a major and minor contour to describe our rise and fall? Okay. We're going to get into this a lot. Okay. Now, the good part about this is I'm going to make you do one of these by hand. After that, we're going to let software do it. Because software can do it. In fact, it's specifically developed to do it. Yeah, just as an aside, we made a lot of topo maps in mining because we are, of course, ripping up land. We bought some software and it cost us 10 grand every month, and we only used it approximately 2 minutes every day. All it did was make topo maps for us. But we were spending hours hand calculating and drawing these, and of course this is back in the 80s. And we bought that software, and we now took all of those man hours we were using to create those, and all we would do is punch a button, and it would create it for us, and then we would drop it back into AutoCAD or MedSystem or whatever program we were using. So, very expensive software, but it took away many, many man hours. It paid for itself the first week that we had it. And we never used it much, but punching that one button sure got a nice test for us. We have software in the room capable of doing all this. We will do some plan profile drawings. That's what this is about. Plats. This is your subdivision. Again, that goes with these drawings up above. We are going to be out surveying and staking. Thanks to administration, last year we got a new tool in here, so you're going to see two types of surveying in here. We're going to do a manual method that's done with what's called a total station. This is the most accurate surveying method we have to date, so we're not getting away from it. We also now have a GPS system that we can also use, which is single person. So we will be doing that. And then also, I plan on pulling out JUB. They've been very good about supporting us. They're gonna bring in a robotic system, I think, for you to see. And I also mentioned the other day, I think Glanbia is gonna bring over their point cloud machine. That will also allow us to see that technology. These two, I don't know that I'm gonna have time for these in the 4 weeks. So these two may go away. That's GPS and GIS. Did anybody take those courses as an elective? Because it is listed on my elective courses. Nobody this class took those. You all know what GPS is, right? Okay, Google's tracking you all through GPS right now, right? Except for me. I'm the only one that doesn't have a smartphone, right? So you all have GPS chips. That's surveying by satellites, right? So that's bouncing off the satellite. If you hit 2 or more satellites, we can triangulate your position. So therefore, we're using a global positioning system. Survey now uses this system. Keep in mind that many times GPS is not accurate enough for us to use it in the construction fields. It depends on where you're at. If I'm down in the bottom of the Snake River Canyon and I can only see one satellite that's above me because the walls are blocking everything, then I can't use GPS down there. Can't use it if you're under trees. You can't use it inside of a building. That's GPS, so we're surveying by satellite. Now, in the last 5 years, that technology has gotten sub-inch. Okay? So we can now get close enough to get within an inch doing this, which is good enough for pretty much everything except for sewer lines. Those need to be much tighter. GIS stands for Global Information Systems. This is the software and how we handle that data in the office. So there's 2 separate systems here. You have GPS, which locates geographically. You have GIS, which is how we manage this data in the office. If you work for any city, Idaho Power, BLM, Forest Service, they almost are exclusively GIS for their drafting software. The predominant one there is called ArcMap. That's the predominant software for that. Okay, so I don't know that we're going to get to these 2. That's the topics we're going to cover. Everything else will be the same. Okay? So we'll try and be done by 10 each morning and move into a lab environment and move forward. All right, if we're going to talk about the civil drafting field, we probably ought to define it. What is civil drafting? Well, civil drafting is the drafting that supports the civil engineering field. So conversely, now we have another term. What's civil engineering? Does anybody know? What do you think about this?
Well,
It's our very largest engineering field by far. It's also the one nobody knows anything about because laws, man, you can't do it. Yes, Cheryl.
Isn't it anything that's attached to the ground so that it's actually located on the earth?
That is actually in part of my definition. My my definition is anytime you scratch the earth, you're doing civil engineering. Okay. So, dirt work. As a minor, do you think I was doing civil work? About all I did. Okay. I fall under the civil engineering umbrella with my engineering degree. What else do we need for a definition on civil? Google it. What does Google tell you it is? Not that I trust Google. You probably get a Wikipedia site. You got anything up there, Gabe?
Well, this definition says civil engineering is a professional engineering discipline that deals with the design, construction, and maintenance of the physical and naturally built environment, including works like roads, bridges, canals, dams, and buildings.
Okay. That's fairly all-inclusive. Does anybody have a different definition? and I don't need 2 paragraphs, but. Do you find the same one, Sean?
The first one that came up for mine says, an engineer who designs and maintains roads, bridges, dams, and similar structures.
Okay, so infrastructure, right? Is kind of what both those definitions were saying. Juan, how about you? What's yours say? Same as that one? Okay. Does anybody have anything different?
Mine says they can be found in aerospace industry, designing jet liner space stations.
Okay, so that kind of goes to the same thing. They talked about roads, bridges. You're talking about air flight, but still transportation. Both the same thing. Yes, all air travel is a civil industry. Now, the plane itself is a mechanical industry, but managing an airport, the fly lanes, all that stuff is civil. Yes, Cheryl?
Civil engineering is arguably the oldest engineering discipline. It deals with the built environment and can be dated to the first time someone placed a roof over his or her head or laid a tree trunk across a river.
First bridge, right?
The built environment encompasses much of what defines modern civilization. Building and bridges are often the first constructions that come to mind. Roads, railroads, subway, airports, designed by transportation engineers, a category of civil engineering.
Okay, pretty all-inclusive, right? Majed, how about, what do you define it as? You went to school for this. What did they teach you about it when you went to school?
It's connected with the roads, everything that the people using, agriculture even, and it's connected with another civil branches.
Okay.
Yeah.
So farmers and tribes.
Is agriculture civil? You bet.
Scraps and logs.
Think of it this way. Anything that people need, that's what you're drafting. It's the infrastructure used to support civilizations. I would expand on, Cheryl said it's arguably the oldest. It actually gets its roots in the oldest engineering firm, which is military engineering. There was a discipline on that way back when, where people were clashing and they figured out things to either defend or attack other civilizations. And we called it military engineering. That morphed into civil engineering. In fact, you probably don't remember drafting 131, and this is in your Bertolini text, the earliest drafted drawing was the fortress of Judea. Remember that one? It's in, I think, chapter 1 of your Bertolini text. And it was a fort to protect and add battlements on it. It was 2-scale, dated back, I think, depending on the text. The one text I looked at called it 4000 BC. Another text said 2300 BC. So in essence, we don't know when it was done. A long time ago. Okay. But it's been around forever. Here's how I define it. Okay. And I try and put it all down into one sentence. Okay. Engineering for the public good. That's really how I define civil engineering. Now, there's a couple important terms I want you to recognize in here. Number one, engineering, that's building, right? An engineer is an applied scientist. So they take all the science courses you need, but their job is to take science out of the laboratory and put it into production to help society. Okay, that's what engineering is. Okay. For the public, that's civilizations. That's all public. And then I put this last word back on here. For the public good. That has different meanings to different people. Okay. So you need to kind of come to grips with this a little bit if you do this type of work. Okay. In essence, and let me use 2 industries to kind of talk about this. So mining, my industry. Is everybody on this planet a fan of mining?
No.
It's a very contentious industry, isn't it? I mean, all mines get sued, every single one. The hardest part is getting permitted. And multiply, for good reason. Okay? We do have bad actors in all disciplines. the thing you gotta know, can you live without mining? No, you can't. You can't live without it. You wouldn't be sitting in the chair you're sitting in. You wouldn't be writing notes. You wouldn't have got here today if you didn't have mining. So it's something that's needed for civilization, but it's not all good. Now, what's bad about it? The pollution that comes off of it, ultimately. It's an eyesore for a lot of people, but that's really, in my opinion, not something that's a concern. It's the pollution that might have. Those of you who went on the tour, I asked CH if they were still involved in the Superfund site, which is pretty much all of North Idaho from the Silver Valley. Richest silver mining district in the world. We've been mining up there since the 1700s. In essence, they put a lot of lead and mercury in those streams, and now Lake Coeur d'Alene is just laced with the stuff. So we are now cleaning that up. Now, if we still mined like that today, we'd probably all be dead. Because we put a lot of pollution out there. At that point in time, the science hadn't caught up with what's going on. Today, we can come in and we can actually mine and leave a site cleaner than when we got there. And we can actually mitigate a lot of these efforts. One of the last projects I worked on, we left that drainage 10 times cleaner than when we started because we took care of all the mercury that was naturally occurring in the soil. And we got rid of it all. So now that stream bed wasn't being fed by natural mercury, which you all know kills a lot of things. So in essence, now the science has caught up with a lot of what we're doing. Many times when we take a project on, we don't have the science to do it. The other industry that's really kind of pretentious in our area is the dairy industry. And for two reasons it's contentious. One, they smell. So it's a displeasure to people, right? Two, we do have groundwater pollution concerns, right? Because we have a lot of manure. Right? Cows eat a lot, therefore they waste a lot. There is E. coli, there's other type of killing germs that are in that. We used to have a bunch of little dairies spread